There's nothing wrong with that.
But you're right. There's nothing wrong with it. It was uh, uh, when they when my daughter was about 15. She plays the saxophone, and uh, we played publicly together for the first time, and we've been doing it on and off ever since. What we used to do is we don't have a band or anything, but we would play at like open mic nights, things like that. And then later on, my sons decided to join us. And so it's kind of a hobby for us. It's not really a something like we do it to make money or anything like that.
So
Um,
it's bonding time for you guys.
it's bonding time, and usually when we go to one of these open mic nights, if we get money for anything, it's just like tips or something, and the kids usually take it.
Like
But
old time's sake.
yeah, but one of my sons he's a percussionist, and he plays the piano. And then my other son plays the guitar. So we go in there and we just like, to us, it's just fun. That's all. We don't, we're not looking to be rock stars or anything like that.
No, but that's okay. I'm glad that you guys have something to do together.
Yeah, because when I was their age, I was an athlete, and as a teenager, my particular sport that I enjoyed was obviously baseball. Um, I I played right up to college, and then afterwards, uh, I would I played organized uh, baseball in one form or another most of my adult life. Either a city league or um, something like that, or say, for instance, a company league, that kind of thing. And I was kind of hoping I would get at least one baseball player out of the crowd, but nah. The thing that is a big joke with myself and some friends is my younger son um, he's absolutely huge. He's I think he's 6'2" and he weighs about 240 pounds, and he looks like a football player, but he has absolutely no interest in sports at all. None. He's my artist.
That's pretty amazing though. You definitely use your right and left side of your brain. Like I don't, it's almost equal because you're a doctor, you're really smart, but you're also
Uh,
a musician.
well, the musician, I've always been a wannabe, a closet type musician. It was something I wanted to do when I was younger, and the opportunity never presented itself to me to do that. And it wasn't until I was about, oh gosh, 40 that I started getting serious with it.
But still, you use your left and your right side of the brain. Like one is, it doesn't seem to be more dominant than the other if you're able to be good
Well,
at
one
both.
of one of the passions that I enjoy now, it's a hobby, but one of the passions that I enjoy is I do a particular kind of portrait photography. Um, and I usually end up recruiting one of my kids and maybe a couple of their friends to pose for me. And what I do is um, I a particular genre that I've been interested in for quite a while now, and I like photographing in costume, and that is steampunk. Have you ever heard of it?
Yes. Yep.
So I'll force my daughter and maybe a couple of her friends, and maybe my son will join us. And um, I have a green screen, so I have them dress in costume, and then I photograph them in a green screen, and then I can manipulate the image on my computer. And so I've created a gallery of photographs, which um, I'll some of these websites will put your photographs on virtually anything, and so I've got a small gallery, you might say, of portraits in various costumes, and it's all steampunk. And because it's a green screen, I can make them look like they're virtually any place on the planet. And so it's a hobby. I just enjoy tinkering with it. And so in a way, you're right, left and right side brain. um, I've always been curious, and it just seems like the older I get, the more I'm willing to indulge a whim of some kind. And this steampunk photography was one of those whims. So, but the guitar behind me is it was a gift to myself about 5 years ago. I bought this one behind me is a Fender, and I've got about 6 other guitars. So, oh. Do you play an instrument, Veronica?
No, I wish I did. But I never did. I want my girls to. The growing up, I mean, now schools offer it. Like kids have more chances this day and age for not having to pay, like the school will pay for stuff like that. But when I was younger, my mom didn't have a lot of money, so that wasn't an option. So, but nowadays kids, the kids have more options with the school will pay for it even nowadays.
Oh yeah. My daughter's birthday was in April, and so I indulged her a little bit, and I bought her a new saxophone. And it's one of the few things in life I'm grateful to be able to do for my own children, and that is not really indulge them, but encourage them, and be able to provide for them so that they can pursue these kind of hobbies. Because the music, like I said, it's kind of a hobby to us, but you know what? It's very relaxing to me, especially at the end of a long day, and I need to decompress, you might say. So instead of getting stupid drunk, I'll just come back into my backyard and plug in my amplifier, and me and my 2 dogs and the stars, and that's it. And then the neighborhood dogs like it when I do that, because they start howling. I don't know if they're happy or sad. Like, shut the hell up.
What kind of dogs do you have?
I have two street dogs, you might say. I found them on the street. One of the dogs, I'm not sure what breed he has in him. He looks like he's got a little bit of lab in him, but he showed up at the emergency room one day. And when the ambulance brought a patient into the emergency room, this dog just darted in through the door, and he's in the ER, and he's a very friendly dog, but it's the emergency room, and you can't really have a dog running around wanting to be petted and, you know, jumping on people. And he was very friendly, and we kept shooing him away. And every time that ambulance bay door would open up, he would try to run back in. And at first I didn't think anything of it, but I went home at the end of the shift, and that night when I came back to work, that dog was still there. So when I left work that particular day, I brought him home with me, and I've had him ever since.
That's really sweet.
The other dog I have, it's kind of the same thing, except the difference was I found him in the neighborhood around my health club. Before the pandemic came along, when I went to my health club, I would play racquetball. I was pretty active in that sport for a long time. And this little dog came by the health club, and it's the same thing. He just wouldn't go away. And so after a couple of days, I just decided to bring him home. So I have these two dogs. The only bad thing about it is that they're both alpha males. So they're in my backyard, and they get along with each other, but you could tell that they're very territorial. And so I've had to take precautions in my backyard because they pee on literally everything. So I can't put anything in my backyard and without thinking, you know, hey, look, I'm going to put this out here. Are the dogs going to pee on it or not? Or are they going to try and chew it or something like that? But I call them Scraps and Brutus.
That's really cool. That's who they did that. Stemming back really quick, before I always wanted to learn the cello. That's what I wanted to learn, but
well, I think you well, maybe not right at this moment, but
yeah, maybe in the future.
Yeah, it's like I said, it's very relaxing to me. It's decompressing, and I just have fun with it. I don't worry about being perfect at it or anything like that. And so I bought myself a little amplifier for the this electric that's behind me, and I'll go out in the backyard and, you know, turn it up a little bit and do my best Jimi Hendrix impression.
So are you going to play after class?
Oh my gosh, girl, I just woke up. I'm not kidding. Like 5 minutes ago. Yeah, the caffeine has not kicked in yet. Yeah, or should I say the go juice? All righty, baby. Let's get started here. I think, boy, there's more people here right now than there's been the entire semester. Okay.
Recording in progress.
Okay. I sent the recording out yesterday, everybody, and one or two of you said that you were having trouble opening it up. So I'll resend it to you guys after we get done here. And then, of course, the recording for today won't be available for probably another hour or two after the class is over with. And yes, I will send today's recording to you, as well as sending you the exam and the answer sheet later today. So you'll probably get the recording from today within an hour or two after we end today. And then probably, like I said yesterday, it'll be around 6 or 7 in the evening today that I will send you the exam and the answer sheet. Okay. And then once again, please have the answer sheet back to me by tomorrow evening at 9 p.m. Okay. Thursday, 9 p.m. Okay. So on the study guide yesterday, I finished with plate boundaries, and I said there was 3 kinds of plate boundaries. A transform boundary. First off, the boundaries are categorized. There's 3 different kinds, and what they're based on is movement. How do they move relative to each other? So in the transform boundary, that was one where the 2 sides are sliding past each other. And California's San Andreas Fault is a transform boundary. Okay. The second one was a divergent boundary. That's where the 2 sides are literally moving away from each other. So yes, there is a crack in the earth that is getting bigger and bigger. However, as it opens up, it is spilling out magma, which is filling in, and it's creating a mountain chain. And so the single largest divergent boundary is the Mid-Atlantic Ridge. It's also the single longest mountain chain on Earth. You just can't see it because it's all underwater. It starts from Iceland, off the coast of Iceland, and it extend. Now, this is a mountain range I'm talking about. It's all underwater, and the northern end of it is just right up next to Iceland. And then it runs down the middle of the Atlantic Ocean, where it will eventually wind its way underneath Africa and then head towards Australia. That is a single mountain chain, but it's the Mid-Atlantic Ridge, and the Atlantic Ocean is getting wider and wider as time goes on. The Pacific Ocean is getting smaller and smaller as time goes on, okay? I also said that another example of a divergent boundary is East Africa. And I said that it was moving East Africa away from the rest of the continent. And that very same boundary is also responsible for creating the Red Sea. And it pivots in a northward direction so that the northern end of this boundary is the Dead Sea in Israel. Okay. The third kind of boundary is a convergent boundary. I said that there were 2 possible outcomes. This is when the 2 sides are actually colliding head on with each other. So a divergent boundary moves away from each other. A convergent boundary collides with each other. And there's 2 possible outcomes. And the difference, or what it's based on, is the density of the bedrock that is underneath that continent. So the example that I gave you yesterday was the country of India. It used to be physically attached to the South Pole. It broke away and then began migrating in a northward direction where it collided with Southern Asia. Even though India is not as big as Asia, the bedrock underneath India has the same density as the rock underneath Asia. So when they collided, everybody, the outcome was the Himalaya Mountains. So it pushed the earth up. The second possible outcome, and it's the one outcome that is most responsible for creating the volcanoes on Earth. And this is when the density of the rock between the two plates is uneven. And so the analogy I provided yesterday was that it would be the equivalent of having a big rig 18-wheeler colliding head on with a Volkswagen. So the big rig is going to run over the top of the Volkswagen. So the rock that is more dense is going to slide over the top of the rock that is less dense. And there's going to be the grinding of the rock as the two plates collide head on with each other. The rock is literally going to melt. And once the earth becomes melted or magma, it's a liquid. And so because it's a liquid, it wants to float to the top. And once that magma reaches the surface, it will eventually form a volcano. And so the area where these two continents are colliding and grinding and creating this magma, this is called a zone of subduction. So if you see the question on the exam, most of the volcanoes are found in proximity to a zone of subduction. So all of the Aleutian Islands in Alaska are the product of a zone of subduction. You can't see it because it's, in the case of Alaska, it's underwater. But it's creating the Aleutian Islands. Most of those islands have active volcanoes on them. And Japan is another example. Mount Fuji is a product of this zone of subduction. Where exactly is it? In the case of Alaska, the zone of subduction would probably be somewhere between 50 and 100 miles off the coast of southern Alaska. And you might be asking yourself, 100 miles, that's kind of far away, isn't it? Well, yeah, it is for you and me, but you have to think on a global scale. 100 miles is nothing. It's nothing. So the grinding that I'm talking about is taking place under the ocean about 100 miles south of the Aleutian Islands. But that entire process has created the Aleutian Islands. It's also created parts of Japan. It's created parts of the Philippines. And these are all active volcanoes located around there. So the zone of subduction that I'm talking about almost completely encircles the Pacific Ocean. And so that area around the Pacific Ocean is known as the Circum-Pacific Ring of Fire. And it's where a majority of Earth's volcanoes are located along the Pacific, the Circum-Pacific Ring of Fire. Okay. I said there's approximately 2,000 active volcanoes on Earth. The vast majority of them are located underneath the oceans. There's only about 500 of them that are on the surface of Earth, but hey, that's enough. What more do you need? The vast majority of all the volcanoes on Earth are under the water. We did not discover that fact until the 1960s. We thought that the volcanoes on the surface of the Earth, that was it. There was no more. We discovered that was not true in 1961. What most people don't realize, in 1961, by the way, the space program was becoming the hot topic, you might say, in the news, because we were planning on sending a man to the moon. So news articles obviously focused on all of that astronaut training and everything that they had to do to get to the moon. Well, while all of that is going on, there's two scientists who are going to invent one of the very first submersibles. And they're going to take this submersible and they're going to descend into the Pacific Ocean, and they are purposely dropping this submersible in the deepest known area of the Pacific Ocean. And the deepest place in the Pacific Ocean is 39,000 feet down. And these two scientists went down to the bottom of the Pacific Ocean in, I think it was 1961. And you hardly heard anything about it because most people were more interested in reading and hearing about the Apollo space program than they were about two guys that were going down in the water. So when they descended to the bottom of the Pacific Ocean, by sheer chance, they quite literally landed on the side of an active volcano at the bottom of the ocean. And so in 1961, that's when we finally confirmed and discovered that most of Earth's volcanoes are beneath the water. Okay. Now on the study guide, the geologic time scale, I'm going to cut right to the chase here, everybody, because we don't have time for a lot of long, in-depth explanation. So first off, I want to explain what the eon, era, period, and epoch or epoch is. They are divisions in time is what they represent. So for instance, your personal birth date is divided in time. You were born in a particular year, you were born in a particular decade, in a particular century, and you were born in a particular millennia. And that's pretty much what this eon, era, period, and epoch are essentially doing for the division of time as it relates to Earth's history. So the longest division of time would be the eon. Now, Earth is currently in what's called the Phanerozoic eon. It's in one of the handouts that I sent you, there's a spelling. Phanerozoic is spelled Phanerozoic. E R O Z O I C, Phanerozoic. Earth has been in the Phanerozoic eon for 565 million years. Now, Earth is 4.6 billion years old. We've only been in the Phanerozoic eon for 565 million years. That's only about 500 million years. So for the first 4 billion years of Earth's history, we were in what was called the Precambrian eon. So what's the difference between the two eons? Earth's only experienced 2 eons in its entire history. What's the difference between the two? It has to do with the evolution of Earth's atmosphere. So 565 million years ago is when oxygen started showing up in our atmosphere. So Earth's modern atmosphere began 565 million years ago. So if you somehow had the technology to go back in time, if you went a little too far back into Earth's history, Earth's atmosphere would be poisonous to you. You wouldn't be able to breathe it. So Earth's modern atmosphere marks the beginning of the Phanerozoic eon. Earth is, we already know this for a fact, Earth is heading for another eon, which probably won't happen for millions of more years. But our atmosphere that we currently enjoy breathing is not going to remain a oxygen nitrogen atmosphere. It's going to evolve into something else. And it'll likely end up being poisonous to humans as we breathe today. So the eon is based on the evolution of Earth's atmosphere, and Earth's current atmosphere of oxygen, nitrogen, and argon is 565 million years old. So it's the Phanerozoic eon. The era, Earth is currently in the Cenozoic era. Cenozoic is spelled CENOZOIC. Earth has been in the Phanerozoic eon, or era for 65 million years. And the significance of 65 million years, this is the end of the dominance of cold-blooded animals, and it's the beginning of the dominance of warm-blooded animals. And so in our particular case, 65 million years ago, brought about the end of the dinosaurs and the beginning of the dominance of mammals on Earth. You know, we humans like to think we are special and we are somehow unique and apart from this Earth. And I like to think that we are all a part of this Earth. I don't feel threatened by that. But in the evolution of mankind, everybody, we as a species, Homo sapien, evidence indicates we've only been here on the surface of Earth for about 100,000 years. You may have in other classes, everybody, you may have heard about other ancient forms, early forms of humans that were oftentimes given different names. They're not the same species as Homo sapien, which is what we are. They, for instance, the Homo erectus. We've only been here for 100,000 years. Homo erectus was on the surface of Earth for 2.5 million years before humans came along. And so it's interesting to think about, will humans be here in 2.5 million years? You never know. So the Cenozoic era is 65 million years ago. And it marks the end of cold-blooded animals and the beginning of warm-blooded animals. The period, Earth is in the Quaternary period. Quaternary is spelled Quaternary, Quaternary. Earth has been in the Quaternary period for 1.6 million years. And in recent history, recent Earth history, everybody, 1.6 million years ago marks the beginning of the most recent ice age to engulf Earth. 1.6 million years ago, glacial ice covered approximately 1/3 of the total surface area of Earth. So the polar ice caps would have extended all the way down into the American Midwest. The Great Lakes in the Midwest, everybody, are the product of glaciers, not volcanoes or earthquakes. Those 5 lakes were carved out of the ground by glacial ice. The epoch, Earth is currently in the Holocene epoch. Holocene is spelled Holocene. We've been in the Holocene epoch for 10,000 years. That marks the end of the last great ice age on Earth. It also marks the beginning of human civilization. Archaeologists who dig up old bones, and in many cases, they dig up old cities. The oldest city ever dug up in the archaeological record, everybody, dates to about 10,000 years ago. It's according to our modern way of measuring time, we're looking at about 8,000 BC. And what is the significance of human civilization? For most of human history, everybody, we were living a tribal existence, and we gathered our food by a process known as hunting and gathering. And there's a big mysterious question in the social sciences that originates from this time period, 10,000 years ago. Why did human beings stop practicing hunting and gathering and start practicing modern agriculture? Why did they do that? And the reason I put that question out there like this is that represents a huge cultural shift in human behavior, because a hunting and gathering lifestyle, yes, there are times in your life where you're going to experience starvation and famine, because in a hunting and gathering lifestyle, you are literally eating anything you can get your hands on. Now, that may sound gross and disgusting to some of you, but it's actually a pretty healthy diet, because by eating virtually everything you can get your hands on, it's the equivalent of your small child at home who is willing to eat their vegetables. So you eat a wide variety of food, which is good for you. So what made humans decide to stop living that lifestyle? But nonetheless, they did. Once they started practicing agriculture, everybody, eventually, over a short period of time, their food supply became more reliable because they were growing their own food. Once food started to become more reliable, the population of humanity at large started to increase. Because up until that time period, when people started practicing agriculture, while they were living a hunting and gathering lifestyle, everybody, your food supply was not reliable. You were very dependent on whether or not it rained, because you were eating all the fruits and berries on the tree. So if there was no rain, there's no fruits and berries. You were also following the herds of animals. And if there's no water around, the animals are going to try and find water. So they're going to, migrate great distances to find water. And you have to follow them if you want to eat. And as a result of that kind of lifestyle, when you did have a baby, because your food supply was unreliable, everybody, babies oftentimes did not survive their childhood. The infant mortality rate in this time period is absolutely appalling by today's standards. Young women, by the time they were 20 years of age, had probably given birth 8 or 9 or possibly even 10 times. And of those 8 or 9 children that they gave birth to, maybe only 2 of them would survive to adulthood. Now that you're practicing agriculture, the babies are going to start surviving their childhood, and your population is going to start to increase. And that's when humans decided to create cities. And the reason that's significant, everybody, is because think about the technology that it takes to put 10 or maybe 20,000 people in close proximity to each other. You have to have public utilities. You have to have a way of removing all the waste and the garbage. You also have to have a steady water supply coming into the city. And then, of course, you have to protect yourself. So you're probably building a wall. And then once you do that, now you have to develop laws to regulate the behavior of all the people living behind these walls. So that marks the beginning of human civilization. Human civilization is basically humans living in cities. It takes a lot of technology to put a lot of people in close proximity to each other. So can you imagine what it would be like to live in Visalia and there was no garbage collection every week that comes by your neighborhood and empties out your trash cans? Can you imagine what Visalia would look like if there was no such garbage disposal? Or if we did not have a public utilities system that provide fresh water to you in your shower and your sink every single day, you had to, what do you think Visalia would look like if everybody in the city had to devote some of their time driving out into the countryside to resupply their water by going to the local river? It's not something to be taken lightly, everybody. It's a significant event. So the oldest city ever dug up in the archaeological record is about 10,000 years old. And if you are familiar with the Bible, everybody, that's about 8,000 BC. That would be about the time of Abraham, the patriarch of the Christian faith. He's also the patriarch of the Jewish faith, and he's also the patriarch of the Islamic faith. Don't you find that kind of ironic that three of the major religions on this planet all believe that the same person is the patriarch of their faith? I guess in a way, metaphorically speaking, Christians and Muslims and Jews are kind of like the little children who don't get along with each other and argue and fight all the time. Okay, so that is the geologic time scale, everybody. I'm going to need you to know that we've been in the Phanerozoic eon for 565 million years, and it's based on Earth's atmosphere. We've been in the Cenozoic era for 65 million years. It's the end of cold-blooded animals and the beginning of warm-blooded animals. We've been in the Quaternary period for 1.6 million years. It's the beginning of the most recent ice age. Earth has experienced more than one. This is the most recent, and it began 1.6 million years ago. The Holocene epoch, we've been in that for 10,000 years. The two events that mark that time period are the end of the last great ice age and the beginning of human civilization. Okay. Now, the very last topic is theories about the Earth. There's only two theories. There's many of them out there, everybody, but I've only presented two of them to you. These are two of the biggies. The first one is it's the theory of continental drift. The author of this theory is Alfred Wegener, and he published his findings in 1912. And he came to his conclusions in much the same way that I would argue some of you students did when you were sitting in a classroom and you were bored with the class, and so you were daydreaming, and you were staring at one of the walls in the classroom. And in your classroom, oftentimes, don't you see world maps hanging from the wall, especially in a social science class? If you look at a map of a global map of the entire Earth, the land masses on this Earth, they almost look like a jigsaw puzzle that if you kind of squished everything together, they would fit very neatly as a jigsaw puzzle. The very easy, obvious example are the coastlines of South America and Africa. They look like they could have been joined together at one time in the ancient past. So this is what Alfred Wegener sets out to prove, that all of the land that you currently see on the surface of Earth, sometime in the ancient past, we didn't have all of these continents. What we had was one very large supercontinent, which Alfred Wegener called Pangaea. That is spelled P-A-N-G-E-Y, Pangaea. And it first formed on the surface of Earth about 250 million years ago. And shortly after that, it began to break up into smaller pieces. And those pieces that I'm talking about are today North America, South America, Africa, Asia, India, Australia. These are the pieces I'm talking about. And so the continent of Pangaea began to break up shortly after it formed, and the continents have been moving across the surface of Earth ever since. You just happen to be present here on this Earth when they are located in their current positions. In the distant future, they're not going to be in the same locations. You already know the Atlantic Ocean is going to get wider. The Pacific Ocean will get smaller. South America will eventually make contact with Texas. East Africa won't be attached to the rest of Africa for very long. It's breaking away. So things are in constant movement on the surface of Earth. And Alfred Wegener is the one who published the theory in 1912 that described this process. There is a major flaw with this particular theory, but it's not the fault of Dr. Wegener, because he did not have access to modern technology. We did not discover how is it continents were able to move. You see, when Mr. Wegener published his theory, pretty much the response he received from the science community was, you know, Al, this is a great idea. It sounds plausible. Yeah, I can see all the dry land at one time being fit together in one big, huge piece, but you haven't told us exactly how continents move. And the reason he didn't ignore that, everybody, he just did not have the technology in 1912 to explore that very topic. How do continents move? That does not happen until 1960, when Dr. Harry Hess published his theory of seafloor spreading. Do you remember me explaining to you that divergent boundary that is making the Atlantic Ocean get wider? Dr. Hess now has the technology, and the technology that I'm talking about, everybody, is not just submarines. The technology I'm talking about is sonar. Sonar is basically underwater radar. And Dr. Hess is going to visit the bottom of the Atlantic Ocean, and he's going to discover how it is continents move. To put it very simply, everybody, for the sake of the exam, it's a one-word answer, so you'll be happy with that. The process that is responsible for allowing continents to move, everybody, is convection. Convection. Most of you have an oven in your kitchen. and you may not know this, but it's a convection oven. What the heck does convection mean? Convection is just a word to describe heat that is rising. That's it. In the oven in your kitchen, everybody, the reason it's called a convection oven is because the heating coils in your oven are located at the bottom of the oven, and the heat rises up through the food. That's convection. The heat that is rising from the interior of the earth, this is the rising of the magma. Do you remember me telling you that as the magma, it's liquid and it is surrounded by solid earth material. But because the magma is liquid, it wants to rise to the surface like a bubble in a soda can. And when it reaches the surface, that heat, that convection, is literally making that crack that is in the middle of the Atlantic Ocean get wider and wider. And the Atlantic Ocean is getting bigger and bigger. So what is the source of energy, or what is the process that is causing continents to move across the surface of Earth? Convection. We did not discover this until 1960. So this is relatively new stuff that we're learning about the Earth. Okay, so that's the end of exam 3 study guide. And unless anybody has a particular question, I would like to jump right straight over to the exam itself and go over that. So does anybody need me to repeat anything so far?
No, just a really quick question. So are the volcanoes the cause of the earth moving? And then also, is that what hot springs are?
Volcanoes are the result of this magma that is rising. The volcanoes themselves are not causing continents to move. It's that heat energy that's rising up from the interior of Earth that is causing continents to move. It's also creating the volcanoes. So the volcanoes themselves are not directly responsible for the movement. They're just merely a result of all of this rising magma.
Okay.
Now, your other question, oh gosh, what was your other question again?
Is the heat from the earth, or actually it was before the question was the volcanoes, is that what causes the hot springs?
Oh, the hot springs. You see, as magma rises, it's radiating a tremendous amount of heat. And so there's a bunch of mineral hot springs in Northern California, up around Napa and the Santa Rosa area. And what's happening there is a large body of magma that is probably about 50 miles beneath the surface of Earth, but it is moving toward the surface of Earth. And as it rises, the heat that it is generating is radiating upward. And when that heat, it will eventually come into contact with underground water, and it will create these hot springs. It's not the magma directly that's causing the hot springs. It's the heat being radiated from it. The magma is probably 50, 60, maybe 70 miles below your feet. But the heat is that intense. It's radiating upward, and when it comes into contact with underground water, yes, it heats it up, and in some cases it vaporizes it. So that's where the source of hot springs comes in. Whenever you're in an area that has hot springs, there's probably also nearby somewhere, there's probably either volcanic or tectonic activity in the area. So in the case of California, we have both. California has 2 active volcanoes, and it has a big, huge fault line that creates all kinds of earthquakes. So the Santa Rosa area is approximately, I want to say, about 70 or 80 miles, maybe 90 miles north of San Francisco. And Santa Rosa is probably the size of Visalia, maybe a little bigger. And that entire area is littered with hot springs. So there is a body of magma underneath California that is rising. Okay. Exam number 3, which is the final exam. Once again, 50 questions. There will be extra credit on this exam that is not mandatory. You don't have to fill in the answers on the extra credit if you don't want to. If you do answer them, I will provide you with 10 answer, slots on the answer sheet to fill in your answers. So don't write anything extra, just fill in 10 of your answers on those provided spots, and then that's it. About the exam itself, everybody, the first 10 questions on the exam are fill-in questions. And by fill-in, you're only going to need to write 1 or 2 words. There's no sentences here. You're not going to have to write a paragraph. So located in these questions, for instance, I told you when I explained about atoms, I only wanted you to know 2 pieces of information. One of them was the number of protons in the nucleus identifies the element. The second one, the electron configuration, determines the chemical and physical properties of that element. Those 2 questions are going to show up here on the fill-in portion of the exam. And you only need to write, for instance, the number of protons in the nucleus. That's it, protons. So you don't have to write a paragraph or a sentence. All I'm looking for in the fill-in is just 1 or 2 words. That's it. There are 10 of these questions. It's the first 10 questions on the exam, okay? And the questions on here, those 2 questions are going to show up, protons and electron configuration. The fill-in also contains a couple of questions about the geologic time scale, okay? So once again, just 1 or 2 words to fill in, and that's it. Beginning with question number 11, all the way through to question 35. 11 through 35 are multiple choice questions. And they are going to be questions about the layers of the Earth. You remember the outer core of the Earth is responsible for our magnetic field. The single largest layer inside the Earth is the mantle. The thinnest layer is the one you are standing on. It's the crust. There are 92 naturally occurring elements in the Earth. these are questions that show up on the multiple choice. Okay. So there's questions about the layers, and there's questions about common elements and common minerals. Remember, native elements and silicates. Also, if I give you a question and I ask you identify which one is the ion, and what you're looking for, everybody, is if there's a number on top of the element, that's an ion. If there's no number on top of the element, that's not an ion. Okay. Three types of, these are questions in the multiple choice. 3 types of rock. Igneous makes up most of the crust. It's 80%. Sedimentary was 5%. And metamorphic was 15%. Okay. An example of igneous rock would be granite or basalt. Granite is intrinsic igneous and basalt is extrinsic igneous. Okay. What else? Let's see here. Of the 92 naturally occurring elements, I said only about 8 of them are found in any sizable quantity. This means that most of the elements on the chemical periodic table are found in trace quantities within the earth. Okay. Here's a question that I'm going to ask you, but I haven't talked in a great amount of detail about. I had said that there were 2 kinds of sedimentary rock, clastic and non-clastic. I said clastic rocks were basically fragmented earth material. And rocks are categorized according to their physical size. And so the largest kind of rock is a boulder. The smallest kind of rock is a grain of sand. And then there's sizes in between. Okay. These are clastic sedimentary rocks. Non-clastic sedimentary rock would be the oil and natural gas. That'll be a multiple choice test question. How do we know about the interior of the earth? How do we know so much about it? If you remember, I went on to explain that scientists typically perform what amounts to a sonogram on the earth itself. They're sending sound waves through the earth much the same way that we do when we look at the fetus of a baby while it's still in the womb. There's sound waves passing through mom, and the baby is reflecting some of that energy back towards the machine, and we get a picture of the baby. Well, the same thing is done to the earth, and we get these images of the layers. So the interior of the earth, our knowledge of it, is involved through the analysis of seismic waves. That's how we know what the interior looks like. Also, there's going to be a multiple choice question about the layers of the earth in regards to which one is the biggest and which one is the smallest, which one is the deepest, that would be the inner core, and which one is on the surface, that would be the crust. Okay. When it came to magma, I said volcanic eruptions, when they are violent, it's because there's a lot of silica in the magma. The silica makes the magma acidic, and that makes a violent eruption. Another topic I haven't spoke about in a lot of detail, but there is one multiple choice question on there. And I said that most of the Earth's volcanoes are produced around zones of subduction. There is an exception to the rule. There are some volcanoes that are formed not in association with a subduction zone. These places where these volcanoes occur and there's no zone of subduction, these places are called hotspots. There's literally a hole in the crust of the earth. Magma is coming up on its own without a zone of subduction, and it's creating a volcano. The most famous example of a hotspot, everybody, is the Hawaiian Islands. It's in the middle of the ocean, everybody. There's no plate boundary in that immediate area. So where are the volcanoes coming from? Underneath the island of Hawaii, everybody, there's quite literally a hole in the crust of the earth. Magma is coming up through that hole and it's creating the Hawaiian Islands. The Pacific plate is rotating, everybody. It's rotating in a counterclockwise direction. It's rotating like this. So the coast of California is moving in a northward direction. Those of us here in the Great Central Valley are moving in a southward direction. But because the Pacific plate rotates like this, everybody, if you take a look at a map of the Hawaiian Islands, they're shaped, collectively, the islands, they're shaped, they're shaped like an arc. Because the plate is turning over that hotspot. So the island of Oahu is actually quite old because the island of Oahu is no longer over the top of that hotspot. So there's been enough time for wind and rain to wear it all down. And the volcanoes that are on Oahu are now extinct because they've moved away from the hotspot. The big island of Hawaii is currently over the top of the hotspot. And the big island of Hawaii has 3 active volcanoes. Okay. If you take a look at a map of the earth, most of the volcanic and tectonic activity on the surface of Earth occurs along the west coast of large land masses. So most of the volcanic and tectonic activity that takes place in the United States occurs on the west coast. The same thing is going to be true in South America. Volcanoes are located in all along the west coast of South America: Chile, Peru, Ecuador, Venezuela, Colombia, up into Central America, the west coast of large land masses. Let's see here. The Pacific Ring of Fire is created by this rising magma, okay? And then questions 36 through 50, the last 15 questions are true, false, okay? The single most common mineral on the earth, everybody, is quartz. The San Andreas fault line is a transform boundary. Adding or subtracting electrons to an element creates an ion. That's true. quiet volcanic eruptions create very large volcanoes. They create shield volcanoes. The Hawaiian Islands are shield volcanoes. Native elements, remember, these are the only ones that are dug up out of the ground in their pure chemical form. Okay. So these are the true false questions. Now, when it comes to the extra credit, everybody, it's going to be the ion combinations, and they're going to be the same elements that you've been practicing. You're not going to see anything new. Okay. So all of those elements that I gave you in the handout that you've been practicing with, those are the ones you're going to see on the extra credit. So in a way, I'm giving you a heads up. If you want to go to work right now on creating 10 different combinations of elements, okay, go ahead and do it now. And then when you see the exam and the extra credit, you'll see that the choices are the same as the ones that you have on the handouts. So you'll be able to just write your answers in. Okay. So the only thing I have to, about the extra credit that I need you to follow are those 3 rules. Only opposites mix. They have to be combined in a proper ratio. And in your final answer, you have to write the positive ion first. So the example that I gave you was H2O. Hydrogen is a positive ion, so it was written first in the formula, H2O. And 2 means it took 2 hydrogens to cancel out 1 oxygen. Okay, so that's going to be the extra credit. I will send the exam and the answer sheet out to you tonight, probably sometime around 6 or 7 o'clock this evening. And I want the answer sheets returned back to me by 9 p.m. on Thursday, tomorrow. So there is not going to be a Zoom meeting tomorrow. You will merely be taking the test and then returning the answer sheet to me, okay? I will grade these exams as quickly as I possibly can because I do need to turn the grades into administration. But like I've done in the past, I will email you your grade, okay? So please get these answer sheets back to me by 9 p.m. on Thursday night, okay? And that way I don't have to delay anybody's grade, okay? And if I have to change anything after the fact, it's going to take weeks and weeks to straighten that out. So please get the answer sheet in by 9 p.m. Thursday, and I will send your grade out to you in your email as quickly as I can, okay? Are there any questions? Well, everybody, I really do wish I could have been in a classroom with you. I think we could have had a lot of fun. I could have actually demonstrated a lot of the things that I'm talking about here with you. That would have been fun for me anyway. And I wish all of you the best of luck in your educational pursuits. Don't let this pandemic wear you down. It will eventually pass. You have to keep in mind, this is not the first time humanity has been afflicted with a disease. We're merely the latest version of it, that's all. It will eventually pass. You will eventually get back into a classroom. Don't give it up. Stay with it. If you graduate college by the time you're 30 or 32 years of age, you are way ahead of the game. And if you are a returning older student, okay, it's never too late I am a living example of that. My very first college degree for me didn't happen until I was almost 30. And I didn't become working in medicine until I was in my 40s. So it's possible, okay? Don't give it up. And I wish all of you the best of luck, everybody. And that's it.
Thank you.
Thank
Unless
you.
any-
Thank you.
Recording
Thank
stopped.
you.
So
Thank
bye,
you.
everybody.
Bye.
Bye.